Hello everyone, it has been a while since the last video and now even Houdini 21 has released and I want to make use of that for a new video and take my axe that we made in one of the last videos, you can see it on screen, and we now want to do the texturing inside of Houdini as well. So the video beforehand was mainly modeling it, and then I would say maybe use Substance or another package to do the texturing. But with the new Copernicus toolset, we now actually have more confidence or can actually do a lot of the texturing inside of Houdini. And that is kind of what I wanted to do here as well. So some of the images in the background here is basically what we will be doing. I also want you to keep in mind that this workflow that I'm about to show will work for many other different models. I'm just using the axe as an example since you can model it and now texture it fully in Houdini, but feel free to use whatever you have at your disposal. If you have a model from before or a model from another package, we can always do that as well. To start up easily, we are here in Houdini. We want to make a geometry network because we want to, of course, load in our models to work with. If you have, again, worked from previous video or another model, you can just use a file node and we can then here simply load in the FBX file. I will show you now two ways of using a model. The first way is in case you don't have a model ready, we'll just use the one in Houdini. And the second way will be basically starting off with the X model in a moment. First one, I would suggest using the test models. So we just type in test model and we can use, for example, the shader ball. So this will be a simple model, as you can see here, that we can now use. We're going to, for example, do the UV layout. It does require that you here again recalculate the UV layout. Your UVs look like this. You can modify it to your liking, and then we also need to calculate the normals of the mesh again to make sure that's correct, and then we can give it a null node, which you will also see in the later stages of the video. And this would then be my low poly model. So this will be low poly model. And then for our high poly model, the model itself here, as you can see, is using the sub-D modeling. So we can just simply do a sub-D division and plug it in. And you can see it's doing sub-D. There are other tricks as well to do this, like a voxel. You might see that in a second as well. So now we have this. We also need to calculate the normals here as well. And now we make another null node. And this is then our high poly for a moment. Now this is method number one. Let's go to method number two. And as you can see, this is my 3D model for that file. This is the low poly file. I also have a high poly file, which I'm going to load in a sec. If you don't have a high poly model or you have a high poly model, so there are options to, for example, poly reduce. So in case you have a high poly model, you can poly reduce it. In case you want to have a low poly to a bit more high poly model, I would recommend doing a voxel and then using the smoothing features to smooth the edges, so you have a bit more smoother edges instead of like very harsh 90-degree edges. So these are nodes to help you, but in case you have a high and low poly made, you can just load them in here. So I'm going to do that as well. So now here I have my high poly model, and you might notice that I've colored my high poly model. You can see that I've added these coloring to identify in later on the texturing stages how each part should go. So if I would look at my attributes, you can see that we have a color value, or what we call in Houdini the CD value, on the model. So you can do that as well. So it's stored here in the point data information. You can simply do this by adding a color node and then just applying a color. So of course I will be overriding it here, but you should be able to make a group and select certain parts. So if you can select certain parts, we can then here select certain part. So I recommend doing this because where every part of the model needs to have a different material. So I use this coloring technique where I did that also in Substance you could do to easily select different materials and mask them out. With that said, I also like to place a null node. And this will then be my low poly model. And this will then be my high poly model. So we will now reference this in the Copernicus network. It's easier for us to create a null node. In case we need to plug in additional things, we can just simply rework our UVs or rework our normals or add more data. If you're not happy with the data, we can add them in between. Now let's come to the part where we're gonna then place a Copernicus network. So we're gonna type in here Copernicus network. Now in here, we want to then double click it, and we now have access to a new layer of nodes, which of course is going to be the Copernicus Texturing nodes. In there, we want to type in bake. We can use the bake node itself or the setup. The setup basically comes with a couple nodes. So let's press on the setup, and you will see that will provide us with an import of a low, high, and a cage model into the baker itself here. Now the cage model in theory is optional, so you can, for example, delete it from now. It's not necessarily needed at this point. Now on the low and high poly, let's plug in our models. So we're going to select the low node, and you need to have a path to our mesh. So we're going to select this icon. I'm going to select on low and press accept. Going to do the same thing with high. Click on high, select it, and accept it. So now all these are linked together, and they will be used in our baker. So we can just simply here click on our baker, wait a few seconds, and now we will have a normal map. You can see that there will be a normal map baked for us. And you can see that this actually looks decent. This looks what you would kind of expect it to be. You can of course increase the resolution over here if you want higher resolutions, but for now I recommend setting it on a low resolution just because we just want to work with a couple things first before we crank up the resolution. Now it's still a bit hard to see how well everything will work on our 3D model. That's why we can type in Material Previewer. This node here will plug in geometry and the materials. For the time being, we're going to plug in our geometry, which will be here. So if we preview this material, we will now see our 3D model. And we also need to plug in that normal map. So here, normal into our normal map. And if everything went right, we should see that everything looks better. Of course, the resolution is still a bit lower, so we can maybe go to a 2K resolution. And you can see now it's getting a better resolution. Sometimes what you need to do is here tick the node twice to first update the results, because sometimes it might cache the data. So this actually looks pretty good. And I do want to tweak the Houdini viewport. Now, the Houdini viewport is a quite interesting thing to talk about. They added a few more things as well in Houdini 21. We can also try to switch to Karma rendering and so on and so on. But personally, I just like it to be a fast viewport where I can just roughly get most of my work done, and I don't necessarily need to be fully accurate, just something so I can work fast and don't necessarily need to wait on rendering results. And the new feature that I want to show you here is using the work lights. So let's switch to work lights. So you might not see much happening for now, and that's because we can right click on it and we have multiple options here for work lights. So we can have a dome light, and you can see it fully changed how everything looks, as you can see. You can also here go to physical sky light, and you can see again it changes how things are looking. So it's representing a more physical sky. We can then here also have 3-point light setup. And these are, in my opinion, better ways of getting something a bit more accurate. You can also here right click and enable ambient occlusion, which will make things a bit nicer. And we can also enable shadows if you want that, which in some cases might be a bit too extreme, depending on your use case. So what I would like to use for this video, I might disable shadows, and I'm going to use a dome light setup. Now a dome light setup, if you go to properties, it needs a HDR map. So this is basically using an HDRI and then using that to light the scene, just like in other packages or softwares for rendering. You're often going to use some environment, an HDR environment map, to get something a bit more nicer and realistic. So we can click here on this icon and plug in a map. Now this will open a menu, and I will just go on the standard Houdini HDRIs. So these are some Houdini standard HDRIs, and we can just choose one of these. So let's go with this middle one here, and let's see what that gives us. So you can see that gives us something nice. The feel of it is I would say pretty good. So I'm kind of going to stick to this. So you can increase the intensity, you can play around with the exposure, some more tints and rotations, but in generally I'm going to keep this to 1 and to 0 if it was. But feel free to play around with this, and if you switch to other maps, you can see we have a lot more settings for each of these. So this is sort of like a bit more secret menu that has more properties on our work light setup. But personally, I like the dome light and filling in one of the HDRI's maps. So this looks actually kind of pretty cool to me. It looks like a nice workable rendering of this 3D model. So now I can get started to actually fine tune what I want and how everything should go. Now, I do want to go back to my baking notes, and I also want to show you how the cage works in case you're making a 3D model and maybe the baking didn't go as well as you planned it to be. We can also use the cage option. So by default, the tracing mode is set to the surface of the normal. So it will sample the surface of your low poly model and use that for the raycasting and seeing what areas of the high poly, the low poly hits, and so on and so on. You can also switch this to a cage mesh. So this means your cage mesh will be used, and we can actually customize this. So here I have not plugged in a cage mesh, so you can see it kind of doesn't work out. So let's go back to our setup here. We can make a bit more room, and I will do a peak. I will plug it in over here. And with the peak node, you can see that we can just scale up the mesh, as you can see. Now, we don't want it to be too much. We just want it to be a little bit. Another thing that I've also not really talked about is the scaling difference. When I opened up my model, usually you need to make sure the scaling is adjusted. We wanted to compare. We wanted to make sure that when we make a cage that everything is just outside that area a little bit. So sometimes I would go even in small ranges. So just like this. So just like a little edge around that model. Now, what sometimes can help, this is like a very simplification of making a cage, is recalculating the normals and not just on the mesh itself, but on the points rather than the vertices. So you can see this does make a difference. If you see it here, maybe I can recompute normals. So you can see this kind of makes a difference in those shapes. You can see it moving here, right? So this will make a difference when we bake. And now let's grab another node. And instead of low poly, let's call this cage. And let's go back to our Copernicus network. I might trigger the bake again. We first of all need to go to cage, and let's plug in our cage. Accept it. And let's plug in that over here. And let's see what the results looks like. We can also here again preview the material. And this is then our result. So in some cases, the baking might be better. In other cases, it might be worse. As you can see here on the blade, it kind of looks worse. That means we kind of need to go back and tweak our cage. What we could try to do is lock our 2D viewport and go back to our node network, go back to the peak node and play around with this value. What if it's 0.2 in this case? And you can see now it does help. So this is the part where you have to go a bit back and forward to see what works. And this in case 0.4 in my case works. In your case, if you have a different model, different scaling environment, there might be other values you need to play around with. So go back and forward to change the distance so you can fine tune to the bake you want. You can also custom model and change the model itself and vertices. But I think in this case, this kind of looks roughly like I want the result that I want it to be. And I think my model looks pretty good so far. Now let's go back to our Copernicus network and let's get started. Talking a bit more about the baker that we have, you see that we have a lot of different outputs here, right? So this is like what you would expect from a baker. And we're going to be using a bunch of them. Looking closer at these, they are by default actually turned off just to probably save on a bit of computation time. So we only want to calculate what we actually need. And this is the kind of point where we can turn on what we want. And we're going to here go into world space and make sure that we also enable world normal and position. We'll be using that later on. But again, we can also just quickly preview that here in the color. I will just preview it on my 3D model. So let's go to world normal. And you can see that kind of looks like expected. You can also here in the settings, change the different offsets if this is what you want. So you can play around with that. And we can also go to position, the position data. This is what the position data looks like. And again, there are options here to play around with based on the values you expect it to be. Now, we're probably also going to use things like ambient occlusion, which is turned on by default. So here, the AO value. We can also here turn off all lights. And now we can probably see without the lights, without the normal map and the dome light. So this looks also kind of what you expect it to be. You can try to play around with the samples and distance if you need to. We can also here enable curvature, a very useful map that is often used. You can see that my curvature doesn't give me the exact result, and that might also be partially because of the scaling of the model. So I might go here to our distance of how curvature is made, and let's increase this value and see what it gives us. And you can see this is more of the type of curvature data that I'm looking for. So a nice values of the convexity and concavity values. Further down, we also have things like edge. We can maybe see here what an edge mask is. So let's plug in the edge over here. And again, we might need to tweak values. So let's increase the radius. So you can see that we have some nice edges going on over here. If you want more edges, we can also here lower that angle. So it's based on the mesh angle. So if you put this to, for example, 11, we will have a different result. So you can see that you can play around with this until you get something that you would like to see. This kind of could be useful for certain effects, and you can also choose the convex or concave mode. So based on what we will do in the future, this map could be useful, or the curvature map could be useful. They kind of are similar, but also different. If you're just used to curvature, you can just take curvature. Further on, we have cavity, thickness, and height. These are some other maps you can use as well. But for my use case, I will mainly focus on things like ambient occlusion and curvature values and so on. Now, there is one value that we are missing, and that is, if you remember, we actually made a color value. Oh my, if you put it still locked here. We actually had a color map on that high poly. So if you remember, we have a color, which stands for CD, on our mesh, and we would like to bake that information on that texture. And this is in general, anything you want to bake from attributes to your low poly is not possible. So we can here custom attributes. You can just click on the plus icon. We're going to type in CD and set this to an RGB value. Now to preview this, we can just here plug in that custom value in here. And now you can see that I have my map like this. Now you might see in my case that we see kind of these UV seams or patches, the border of it, and this can be fixed. You can also, for example, see it here happening in the position, where we can clearly see that the border of the UV, and of course you can try to increase your resolution to lower this, but in reality what most people will do, or what most packages will do, is use the boundary filling option. So it's turned off by default, so we can just quickly turn it on. And now you can see it's sort of like filling that. Maybe we can look at here in a texture space. So all it does, if I would turn it on or off, you can see that it's coloring that edge in our same color of our UV. So it's basically extending the color outside the UV shells, outside of that UV range. Now I did notice a little issue. If I look quickly at my custom color, you can see that it's not happening here for some reason. I'm sure SideEffects Houdini will fix this in the future. For now, there is like a little bypass trick you can do, is you can simply add a second custom attributes, but we don't have to use it. You can just turn it off. And if you just wait a second, and now it will work. The only thing that happens is the custom data now suddenly holds two values. And this is something new added in Houdini, which is you can sort of pack multiple textures into one, and they call it a cable. So it's a cable of multiple informations or multiple streams of data. So we can here have a bunch of things, and we want to then unpack the data. So we can here have a custom packed information, which holds multiple textures. We can simply say here, plug it in and click on get fields from inputs, which will be our color and our random output, which is probably nothing. And you can see it's already working here now. So this is again here with that filling, and this is on and off with that border fill option. And now as you can see, everything works, and it's a clean baked out mask that we could use. And this of course automatically brings me to how can we mask different colors. Now I'm going to change my viewport and my layout a little bit. I'm going to make the 3D viewport a little bit smaller because I'm now going to use my node space that I have. So we will build a bunch of stuff over here, and we're now going to create the masks. Now from here, there are some ways or different ways to do masking. This is one specific way that feels very familiar to, I guess, other packages. We're basically going to say like, hey, if this color is red, then just sample everything from red and so on. And this is actually what is called a chroma key, which is, for example, as you can see, the icon hints more to like a green screen thing, which we don't necessarily use in games, but this is what we can use. So you can see that it will take a part of the color of the map. I can here look a bit like this. So you can see that we're sort of like trying to filter out parts of that map. Now, what I will do is I will disable here the pre-multiplier. So this is the actual just normal result as we usually would see. I'm going to maybe go on unlit mode. And now I can just simply click on colors. And I'm going to make 3 different masks. So first of all, I'm going to make a mask for the handles. I'm going to click the eyedropper icon. So I can now select the color. And this is my handle. I kind of knew what this is. So we're going to click on that and press enter. So that's my color. Now to see it actually properly, I'm going to place a null node. And I'm going to just here preview the matte result. And this is kind of the mask that I have. This will be the mask that I will use. This will be for my handle. So the black values are my handle, the white values are everything else. So we can copy paste this idea, and of course I'm going to name this. So this will be the handle mask, and I'm going to copy paste this to make another one. And this will be, for example, my bolts, the bolts that I had from before. So I'm going to here click on the eyedrop, and I'm going to click on my bolt and press enter. And now I will here see if my result was all right, and that looks okay. You can see some here spickles. You can always fine tune values if you really want to. You can always just grab and overwrite elements yourself. But I guess I just trust the system, and I think that will be correct. We're going to give this a name called bolt masks, and one more, which will be my mid panel. And the blade itself could be a base material, and then I just overwrite and mask everything else on top of it. So for that, I'm going to go here again and click on the eyedropper. Oh, I'm going to go here, click on the eyedropper. I'm going to click on this pinkish color and press enter. So now we have that mask too, so we can use that later on. So this will be the, I called it the mid panel mask. Mid panel mask. And these 3 are now our main masks for in a moment. So now it becomes more interesting. I have all my baked maps. I have separated the different masks that I want to use. Now it's just a matter of making a material and then copying the materials or having those materials with different properties to represent metal or plastics. And I'm just using and blending the masks that I have. And that way I can assemble my axe with the different properties and materials. Now, the way that I will do it is I will make one tool. So I will make here what we call a subnetwork or an HDA. I will make a simple tool that, for example, holds material properties, and I will copy that around and I will just slightly change it to whatever I want or whatever I need in some situations. So that way, it's kind of working with smart materials and substance, but in this case, we could call it procedural materials or procedural wear. Um, so we can kind of think about it in the same direction. So we don't necessarily have to come up with specific workflows. We can come up with that. So this network, so this will be a tool in a moment. We need data for this to work. We want it to be procedural. We want it to be smart, adjust to different models. So if you would be having a different model, just simply plug in this tool and it will roughly work as well. So for that, what we need is multiple inputs. So I would like to have multiple inputs, and we're going to have mainly mono inputs. So we will have an AO map, and we will have also the curvature map. So curvature. This is going to be mono as well. And we will also then have what I would call the pattern map, which is a custom noise map or pattern map to lay on top of everything else. So these are all different outputs. And then we have, these are all the inputs, as you can see. So we can just simply grab our ambient occlusion, our curvature, and a pattern, which in this case for now, I'm just going to take a noise. So let's take here the fractional noise. As you can see, it will just be a noise like this, and this will be as a temporary test. And this will be a testing material, and I will grab it here for preview in a moment. Output of this result needs to be a material. A material can consist of many different elements. Like you can see here, a material can consist of all of these maps. Usually in games, we would work with a color map, a metal map, a roughness map, a normal map. These are like the most common things. And all the other maps we don't really want or need. It's kind of like a bit much to always store or save. So we're going to focus mainly in this video, we're going to mainly focus on getting a color and a roughness value on the material. So that means that this output, we have a material, but it's going to be called here a cable. And again, a cable can consist of many different textures. Just like we have here with custom value, we can here unpack and pack cable data or multiple textures into a one. Once we have that done, I'm going to select my subnetwork. I'm going to right click on the node and say create digital asset. Doing this, we need to come up with a name, which could be material procedural wear, something like this. You can name this anything you want. We can add a few more things if you want to, but we can keep it pretty simple here, and I will just simply click create. When that is done, a new menu will pop up, and we will have here then future interfaces and options, or we can also rename our cables and networks in and outputs. So you can see here that this is still undefined. I'm going to make sure it's set to cable. So under in and outputs, our output network should be a material that is a cable type data. I'm going to press accept. So now this is made into an HDA. So if I would type in material, I have now a new node called material procedural wear. So I can place this multiple times in the future. So let's now jump inside. Let's here create some stuff. And let's start out by just simply defining a color, a constant color. So let's say my color, we should make sure it's set to here RGB. Let's pick, let's go with some blue. This will be the default material color, a blue color. From this will be our base color. And of course, we will change this over time. What I like to do with this is I would also immediately like to use our pattern on top of this. And you can just simply do it with a blend way, but I personally like to use the hue saturation value way. So hue saturation value, this is our source, and our mask value is our pattern. So by default, if all the values stay the same, nothing will happen. But as soon as we start to change here the value or the saturation, you can see that we can create some interesting effects. So these are again sliders that we can expose to our interface in a moment to create the look that we want. So by default, I will probably keep most values the same. Maybe we can here lower the value a bit so we have some of a hint of the pattern, and maybe we can just change the hue a little bit, like so. I think that's not too noticeable and a bit subtle, but of course these parameters and sliders could be changed by the user in a moment. Now, on top of that, what I'd like to do at this stage is to use the ambient occlusion and blend it on top of it. Or we can also use the hue saturation way as well. There are many different ways on how to do it. So let's say you're going to use a blend node. You can see that the blending operation expects an RGB, but our AO, of course, is set to mono. That means that we need to go to mono to RGB. So we can do it like so. And now we can basically blend those maps together. You can just simply use multiply, and then you can see we can blend our AO in there. So this is one way of doing it. Just simply converting the mono to an RGB. You can also color the AO into a different color, so you can again make it into something more specific. But it can also again be a good idea to use that trick that I have here, using that as a mask. And now we just simply lower the value. Or in this case, my AO needs to be reversed. You can just simply use remapping. And we're going to here invert our range. So click on this button to invert the range. And now we can basically now start to color that AO. So we can make it a bit more brown dust feeling in there. As you can see, now we start to get everything into shape, and maybe we want to preview this because we want to work on this. And I'm also maybe going to assemble my cable. So let's type in cable, and we're going to make a pack, a new version of our cable. So we're going to here plug in our color. And for now, for the roughness, I will just use a constant. So this will be the main roughness, so main roughness value. And this could be set to 0.5 as like a default roughness, so nothing too special, and plug it in like this. We're going to name these elements. It's good to name them. So we're going to have base color and roughness. This is all what we're going to cover in this video. Feel free to add normal map, metalness values, and other values. This is what we're going to cover as base color and roughness. Once that is done, we can just simply here use this as an output. And now we have a new material here that we can use in our material node. Now, we cannot just simply drag and drop this. We need to unpack. We need to unpack it with the unpack node. And then we need to set fields, and it will sample the base color and roughness automatically. And we just need to simply plug it in over here. And now we can see our model with that value. We can also here plug in our roughness. And this is now also a nice way of working. Now, the reason, if you're asking why we are doing the whole packing and unpacking, is in the future, if I would place multiple material nodes, and let's say this is a different material, only thing I have to do to combine these with our mask, so we can simply blend these materials together. Instead of having to blend multiple chains of networks together, we can simply make a material that has all the maps, and we can blend them with a mask. And in other words, our masks will be these that we created. And it will be very quickly, or a very fast way to now add and layer things and materials on top of each other. So let's now finish up our node. This is our main node that we're going to use in this video. So let's focus here more. Let's lock our viewport over here, and let's jump into our network, and let's fine tune a bit more. So you can see that our roughness normally should work as well. So you can make it glossy if you want to work with it. Make it a bit more glossy. So we have our AO value. We can boost this as much as you want. I'll probably keep it low like that. You can also go into uncoloring mode if you want to see that as well. Now let's go on to the curvature value. We're going to use a remapping for that as well. So let's place a remap node. If you want to preview it, I would suggest we can do mono to RGB. Then we plug in our remap and plug in our curvature like that. And now we can use the remapper to kind of control what areas we would like to capture, as you can see. So we can fine tune the roughness areas like that. So you can really get something more like this. Like this is kind of what we want from the curvature. We can do slightly blur it and distort it if you want to as well. So either we can increase the sample count on the Baker to get a bit more cleaner results. We can also do a little blur. So here, if we do a little blur, but not too much, as you can see, it will destroy it too much. So a little blur, not too much. And then we can do a very typical thing, which is going to be called the distort by slope. And let's make some more room here for a moment. So plug in the blur in here, and we need a noise on top of that. I will go with the fractional noise. Put it in over here. I will probably set the sizing to something else, but we can see that in a moment. So let's plug in our distortion, and you can see it's probably by default a lot. So what I often would do is in our slope direction is we have a scaling value, so we can lower this a lot. You can kind of see what it's doing. You can see the breakup we have. It does create, of course, a very nice, cool effect, and that's kind of what we want, to be having a less consistent edge. And the noise will also be reacting to that. So if I would change here the noise type or the noise frequency, you can see we can have more or less chips of it. We can also go here to different modes to have like a minimum or a maximum. I think maybe minimum works nicely to have a little bit of more chipped feeling in there. And that's kind of often what we want as well, to have not a perfect straight line, but to have like some chipping of it. And this is where if you would again play with that noise, you will have more or less of that feel. So I think something like that actually kind of works well for me in my case. So this is a really nice mask to use. And again, we're going to use here our node like we did before. Plug it in. This is our mask. This is our value. So I'm going to go back. This is my base color and delete this ramp that we made. Now here we can again play around with that. So we can boost the value. So we have a little subtle edge here. We can also go beyond to, for example, 6, maybe too much. So try to balance this in. We can also play around with that saturation a little bit. Maybe a little hue shift, getting it into a slightly different color. Let's see how it looks like in our material. And I think that looks all right. So we have little damages and chips over here. We can also here in generally have a mask value. This could be, for example, be controlled by the user. If they want to just lower this down or increase this, they could basically come in and be like, oh, this is too much, or I need more of that. If you go for something more realistic, you often want to make it a bit more subtle. If you want to go for more something stylized, just increase it usually a little bit. There, of course, are many ways of doing that. And that will be our color of the material. So not a special network. Let's now focus on the roughness. On the roughness, I'm going to start out with that main value, and I'm going to blend in another value. So we're going to use the blend node. And with that, we will grab our distortion, and we will here blend that with this node, and we're going to subtract these two. So subtract. And again, for previewing, I might just simply override my color for now. So let's do, again, mono to RGB. I'm just easily previewing this like so. So if you know how a roughness map works, if a value is lighter, it will be less shiny. If something is darker in value, it will be shinier and shinier. So the fact that what I'm doing here means that all these edges will be more shiny in our end result. So we can also go in this blend node, and if we lower the filter here or the blending, we can see that we can maybe lower it a bit down. Maybe I can just keep it to 0.5, and then the user could still control this to highlight the edges better or not. Then another classical thing is blending in the AO. So we're going to use another blend node. We're going to grab our results, and we're going to grab our AO map from our remap. So before we remapped it, so we're going to use that here as well. And what we will do, we're going to just simply do a screen, and let's preview that result. So you can see what it is doing. It's going to make all these areas more lighter, which means they will be less reflective. So all these areas where there could be, for example, dirt, it will be less reflective in the light. And again, we often probably want to control this. So I'm going to keep this to 0.5 as well. And the user can always turn this up or down if they want to have more reflecting areas there. And then the last thing that I can do as well is blend the pattern, the custom pattern the user plugs in. So pattern over here, foreground, background. And we can simply do a multiply. And we're going to set this to 0.5 as well. And let's preview that over here. And you can see that this can bring in some nicer roughness variation from the pattern itself. Again, this setup is pretty simple. It's not too fancy. I'm going to combine, or I'm going to grab my original color here back again. And now I'm going to delete this ramp and plug in our roughness. So let's preview our material. Let's see how that looks like. Now comes the fun part. We're kind of done with our material, and we're going to just simply go into our assets. We're going to go to parameters. And what we will now do is make a custom interface. So I will maybe make a folder. This is base color. And a folder for roughness. So anything that is related to base color, we're going to grab. So we're going to have a constant value. So this will be grabbing that color. And this is our base color. Then here we're going to grab our influence of the pattern. So for that, we can maybe make folders as well. So we can grab another folder. We can maybe make it into a simple folder. And we can just type in the pattern. We can make another folder. This will be for the AO. Another folder. And this will be for the curvature. And I will do the same order as the inputs, so the user has like some consistency in that interface. They're all going to be part of a simple menu. That means that the UI will be a bit more simplified for it. And this node here was for our pattern. You can see where it's linked up to. So we're going to grab here the hue value and the value. You can have as much as you want. I will just stick to these two. Here, this is for our ambient occlusion. We're going to go with a hue value as well, the saturation, and the value. You can also rename this if you feel like you want to rename them. And this will then be the curvature or the edges. So we're going to go here and grab the hue as well. Hue, saturation, and value. And that will be it. Let's go to roughness now. So we have here our base roughness. So this will be our base roughness value. I'll just call it base roughness. Then we have the edges. So we're going to go here and say edge highlights. And then we have here our AO. And we can just simply call it AO amount or AO roughness. And then we're going to here and then say pattern influence. And when that is done, click apply and accept. And if we go back, we now have a custom menu that we've created. So we now have all the options ready to go and ready to be used. So I do notice here, for example, with the base roughness, this slider goes from all the way from 0 to a 10, which of course doesn't make usually sense. So we're going to go and we're going to go to our assets and modify that. So here, base roughness, it should go from 0 to 1, and we can lock this range because we don't want any values outside of that. And now we have a better value. So make sure your tool is saved. We can always go back here and click on save, then right click, and we're going to say match current definition. So now the tool will be locked. The icon is now locked, and now this is ready to be used. So now let's make a couple materials. For example, we want to make a material. I'm going to name it, and this will, for example, be plastic for the handles. So we can go here now and say, I want some blue handles, but maybe we have a little bit less saturation. So I'm going to lower the saturation maybe a little bit, make it a little bit darker, something like that. And again, we can play around with that curvature intensity here. We can play around with that curvature intensity. We can boost that in hue and value to make it stand out a bit more. We can have the pattern influence. You can see it goes brighter, or here changes a lot of colors. I do think for our handle specifically, I want to get like this a little bit more noisy shape into it. So let's see if I can here. Yeah, so I kind of want to have like some speckled noise in there that I would like to see. And this could be a nice start for my pattern. As you can see, so this could be, I think, quite nice to have. And we can also have some roughness variation, as you can see it, where I influence the pattern. And I think that's roughly it for now. We can always go back and change this. That's why we built this node, if we want to change our material. Let's now combine this with a mask. So let's now make a more metallic piece. So let's copy this over here. And let's now make our base metal, for example. We can create a line that goes now into here, into our base metal. And I do want to now go in here and maybe enable the metalness, or force the metalness to be 1. In a moment, I will override it anyway. We also need a pattern for it. Let's just use the default pattern that was already there. And let's start to make a more metal material. So metal also usually has a bit more lower roughness. So as you can see, I will make it a bit more shiny. So now we have that shiny metal, as you can see here in our viewport. And we can now tweak it to our liking. And we can start to play around with it and then tweak the values to what we want to see. And now let's talk about maybe blending these together. Blending these together is as easy as just placing a blend node and grabbing our plastic and grabbing my metal, and now grabbing our handle mask and using this and redirecting our material line from this node all the way to our blend node. And if we now preview our result, we can start to see that we are now blending these different materials together. And this will be the way on how we are going to do this. Now, there is one more thing that we need to establish, of course. First is the metalness map. The metalness map is basically, in other words, equal to my handle mask in my case, because everything of this X is metal except that handle part. So this is actually referencing my metal map. So I can just take this and plug it here into my metal map. And now you can see that everything is metal except that handle. That's of course less metallic, as you can see now. And now we're on our way to build this better and better and better. Now the workflow will be quite simple going forward. We're just going to blend more of these materials together to create our final look. We're going to create a material, for example, for the bolt. So we have a bolt mask, so we can do that as well. So we're going to copy paste our base metal, and we're going to call it metal for our bolts. And with that, we can also plug in a custom pattern. Another way to create like scratches would, for example, be using a tile pattern. I like to use the tile pattern. Then in there, we can increase how much of divisions we have, but the shaping needs to be here set to a circle. And we're going to go to our size, and we can just simply squeeze basically that shape until we got like these little strokes. And we can then rotate them randomly, set them to varying, and you can just simply start to rotate them randomly. Now we also need to have random position. We can here go to the position value, and we can start to ask to have more randomness in there. So now we can create like this sort of like a random scratching surface. And we also need to here the scaling, set this to varying, so we can have variation in the scale. And this is one way of creating like very, very quick, sort of like a scratch pattern. You can increase this if you want more. It's probably something like this in my case. And this will be my pattern over here. This will be like some bolts with scratches, or we can blend patterns together, of course, or things together. So we can just simply blend this map with this map. Options, maybe an overlay mode, and then put it lightly like so, and plug it in over here at the patterns. And you can now see we have scratches and little details going on. And this could then be useful to texture the bolts. So maybe we can increase the amount of scratches even more. So once we have that, we're going to do a blend again. So we're going to blend our material from before with our bolt material, and we're going to grab the mask, plug it in over here, and now we have a new mask to work with, and let's plug it in. It seems I did it the other way around. It's first the bolts and then the previous material. This will make more sense. I can just always quickly check by just simply making it into this color, and now I can see it's correct. So you can also here color the bolts slightly more darker or lighter. Maybe I go with a bit more lighter tone to build up a little bit more contrast and variation. And now we have this. And then we have one more other mask, which will be the mid panel. So which will be this panel here in between our blades and our plastic. To do that, I can also use one of Houdini's nice features, which is holding Ctrl Shift and Alt. So Ctrl Shift Alt, hold those keys, click on base metal and drag it, hold and drag and let go. We've made an additional copy that has a full reference to everything, as you can see in screen, which has basically a reference to our metal. And now we could, for example, detach the color. So we can right click and say delete channel. Now it's basically detached, and we can make it lighter or darker. So let's make it darker. And let's then blend everything together. So blend our materials like we did before, based on our mask, with a new line over here. And you can see now we are having the exact same kind of metal, but we're just basically overriding some of the properties. We can of course use met as well, so we can simply say roughness multiplied by 2. So it means it will be way rougher, because I'm just basically saying use the same roughness but multiplied by a certain amount, so we can make it a little bit less roughness. Maybe we can say 1.1 to maybe still make it shiny, but maybe a little bit less. So this is a way to build that up. And now we have everything kind of in place. So you can see my axe already kind of looks pretty nice. So we have our base materials, and it looks pretty good. In my opinion, it starts to look pretty well. Now I do want to talk a bit about adding a triplanar texturing as well. So in case you want to do that, there are a few things we need to keep in mind to do it. First of all, let's place here a triplanar node. This node itself, as you can see, needs a position and a world map data. We kind of already have this from our Baker. So here, make sure that if you scroll down, we enable world normal and position. So we're going to grab our position and world normal. We also need a texture for it, and we can load in custom textures by the file node. And that's what I will do. You can also just simply place a noise and then use this to be as your texture, for example. That's also a valid option. I'm going to use one of my Megascans textures that I had from a while ago, and I will use that to display on our mesh. Now let's preview this on our model by just simply grabbing the output and previewing it over here, overriding the base color like we did before. I'm going to disable the light so we can see what's going on. So you might notice that it's not really working by default. And I figured out that there are some ways around it. So this node is expecting the position and world normal data in a specific format, and the Baker is actually giving you that in a different format. So what you need to do is you need to set our position here to a non-stretched option. That's the first step. You can see now it gets a little bit better. And we also need to have our normal world space from -1 to 1. And now after that is done, you can see is that we have now our triplanar displacement like you expect it to be. So in case one of these are off, you will notice it that there will be weird stretching or artifacts. So these two are important to set correctly. So this is now correctly set up, and I can now use this in my metal. So beforehand, what I did is I would basically blend this in. So I will now blend my noise that I had before with this. So now I just simply multiply these a bit together, and I'm going to change the order here like so. So I can have a little bit of noise, but not too much. And this will then be my new metal value. And also we probably need to plug it in over here as well. Like so. And let's go back to our material node. And we're going to plug in our base color. And we can now see our model back again. And let's take a look at that. So we can see we have a bit more interesting effect going on. You can see that some of the roughness and coloring here is a bit more interesting. We have like the texture is doing its job. And now we are almost done adding a bit more dirt, which could be used by the AO map. So let's say I want to layer or blend another value on top of this. This will be done by the same way we have been doing things for a moment now, which is just going to grab our base material or a base material node that we made. We can just call it dirt value. We can just directly now plug it in into our material to preview it. So this will be my dirt. And we can make the roughness very high. So this is my dirt map. It's very extreme. You can see it's a very rough layer on top of it. So let's now make a map for it. So we're going to use the blending options again. And what we want to do is that our background is our main material and our foreground is our dirt. So we can also use the blending options here or the masking options here to lower the influence. First thing I want to do is getting a remap, and I want to use my ambient occlusion and remap it. I want to invert the range, and we sometimes want to boost it or control it. So I think in this case, I'm going to boost it. Sometimes I really like to boost it and then lower the option with the blend node that we have here. So we can combine a bit of both. On top of that, it's also really nice to break up the consistency with like a slope again. So slope by direction here, plug it in. We're going to use a noise. I'm just going to use the fractional noise here. So we can plug it in like that. We can increase here to a very like low speckly noise. Here angle 0 and the scale maybe subtle. Let's see how much influence it has. We want to have it very, very subtle. And here as well, there is also a scaling slider in here as well to make it a little bit We don't want to go too crazy. And we can also here try out like a maximum or a minimum value. Let's see, maybe maximum. It's hard to say sometimes in this map, so that's why let's grab this result and plug it in over our blend here. So let's here grab our results and plug in. Now you can see that we added this dirt layer. Let's redirect our line of our material in that blend. And now let's preview our material. And you can see is that we have now added this dirt on top of it. You can see it's quite extreme, like it does add a lot of dirt on our blade or on our axe, so it could be cool. Let's maybe see if we can play around with that frequency. I like it because sometimes it adds lots of cool detail. You can see it adds a little bit of interesting effects. And the way to now control it better could be using the remapping. So we can just simply here lower this remapping. Maybe we can do that a little bit. I do like it to be strong. And then we can just simply go to the blend node and then here blend that slightly. And I think this is a really nice way to do it because we can nicely control. So it's sort of like a stacking layer in system where we can nicely control. So you can see there is some roughness variation going on. And I think that's quite nice. So yeah, I think you have the main idea at this point of how everything could work in this setup. So we create a very powerful material tool and you can enhance this and make this even better. This is just a simple example, I would say. And now to do a few more final tweaks, you can always override our end results. We can do a little bit of post-processing. So we can still plug in a map here that exclusively targets the base color. And we can, for example, play around a little bit with the hue, a bit with the value. We can then do some last final tweaks, like maybe, hey, this is actually nicer. So yeah, we can also do a sharpen. If you want it to be a little bit more sharpened, you can see we can sharpen the details. We can have a lot of options. So this is without the sharpen. So maybe a little bit sharpen won't hurt, maybe not too much. But I think it's nice that we all have these features now in our hands. The same with the roughness. If you feel like the roughness needs to be better, we can then simply remap it. And we can here play around with that and maybe control certain parts of it. So we can grab at a later stage still a control of some of that. This is how you can start to texture now in Houdini. The setup should work with multiple models. Of course, the only hard-coded element I would say is the coloring selection. So there are many ways of how to make these masks, but this is a specific way of doing it. Now to export everything, I also want to show that is type in the output. So output images. Plug in a material. As you can see, a material is also a cable connection. We can go in here and we can see that this is also a cable that is packed with all these maps into it. Now, the thing that we want to do here is that we're going to select at the bottom here is we want to click this button and it will basically grab all of these. You don't have to do all of them. You can just simply right click and start deleting them. Or you can just simply delete all and just fill them in manually if you only want to have a few maps. And then one more thing you have to do here is give it the proper name. So you're going to have this called, for example, X. And then we want to give the layer name, which is actually a special name for it. So layer dot, let's say PNG, for example. And this will automatically use the name of our layering. So it will fill in base color, metalness, and this will create all the necessary images that we have made. We can also here override resolution and other color spaces, which is also important for you to know. For example, sometimes with a normal map, we want to enable a raw output of it, which sometimes can make a huge difference. So yeah, I think I have covered enough, and I hope you liked this video. I hope you liked this deep dive into some workflows of thinking about how you could use Copernicus for texturing models in a more procedural way, a bit like Substance Painter and Designer type of deal. So we can create all types of different workflows now inside of Houdini and make something that really works for your workflows or pipelines. This was it for this video. I hope you enjoyed it. Feel free to like and subscribe to support the channel. Thank you so much and see you on the next one.